Brad Williams, Frugal Finance, present value. When we compute future value, we're asking questions like, how much will I have in 10 years if we invest $1,000 today at an interest rate of 8% per year? But suppose we want to know how much to invest today in order to reach some target amount at a date in the future. For example, if we need to have $15,000 for a child's college education 8 years from now, how much do we have to invest today in order to accomplish that goal? To find the answer to this kind of question, we need to calculate the present value of a given future value amount. We're just reversing what we've been doing. Determining present value is the opposite of calculating future value. That is, it tells us the amount you would have to invest today to accumulate a specific amount in the future. Here's how to calculate present value step by step. I've gone over this repeatedly, but let's go over it again. Suppose we want to have $1,000 1 year from now and can earn 10% interest per year. The amount we must invest now is the present value of $1,000. Since the interest rate is 10%, we know that for every dollar we invest now, we will have a future value of $1.10. Therefore, we can write present value times 110 equals 1,000. Then the present value is given by 1,000 divided by 1.10 equals 90909. If the interest rate is 10% per year, we need to invest 90909 in order to have $1,000 a year from now. Simple, isn't it? Now, suppose that $1,000 is needed 2 years from now. Clearly, the amount we need to invest today at an interest rate of 10% is less than 909 for obvious reasons. Since it will earn interest at the rate of 10% per year for 2 years, use the following to calculate present value. Well, all we're doing is 1,000 equals present value times $1.10 to the power of 2 equals PV times 1.21. Or PV 0.12 negative 10,000. 826. Right here. 826 invested now at an interest rate of 10% per year will grow to 1,000 in 2 years. Calculating present value is called discounting. And I've been using that word, but I haven't defined it. So here it is. It's called discounting, and the interest rate used in the calculation is often referred to as the discount rate. Again, I've been referencing discount rate from the very beginning. Discounting in finance is radically different from discounting in retailing. In retailing, prices are reduced to sell more goods. In finance, we use present value to figure out what a company's future cash flows are worth today. To distinguish the two kinds of discounting in the world of business, the calculation of present value is called discounting cash flow analysis. Intrinsic value. The general formula for the present value of $1 to be received in n periods from now at a discount rate of I is present value equals 1 divided by 1 plus I to the nth. This is called the present value factor of $1 at an interest rate of I for n periods. Present value of $1 to be received 5 years from now at an interest rate of 10% per year is equal to PV 1 divided by 1.1 to the fifth, which is equal to 6.092. Here you go. To find the present value of 1,000 to be received in 5 years at 10%, we just multiply this factor by 1,000 to get 620.92. How many times have I said we have that factor? Well, there's the factor, but Excel does it for us automatically. Since discounting is just the reverse of compounding, future value, we could use the information that we use for future value factors to find present values. Instead of multiplying by the factor, however, we divide by it. Thus, we can find the present value of $1,000 to receive in 5 years at 10% by multiplication or by using Excel to derive the present value factor. Here we have present value is equal to 1 divided, notice divided by 1.1 to the fifth, and there should be a caret there, equals 62092 times 1,000 equals 620.92, or with Excel, we can use the present value function. So here we have 6.02, all we did was 1 divided by 0.1 to the fifth, it's a 6.2, and then you could just multiply that times 1,000. Or whatever number it is, looks like 1,000. Or we can use this present value, and then again, you can just hit the rate. 1, number of periods, 5, payment, no payment, future value, 1,000. The question that is posed is, Brad, why do you have this annual monthly compounding? This should be annual monthly compounding factors. They're just there as a reference. Why? Because when your computer blows up on you, you're stuck, you need to solve a problem quickly, present value or future value, you better be able to have a factor. You better be able to compute the factor. The factor is this formula. This is a monthly annuity. Notice the wording, 3-year annuity with monthly compounding. You could say annual annuity with monthly compounding and change it. This would be 1. This would be 1 minus 0.06. This is just an example to show you what you need to do if you need to compute an annuity formula. If you need an annuity with annual compounding, notice the different structure. This is a 3-year annuity with annual compounding. If you need 3-year discount factor with monthly compounding, here is the formula. It's purely for reference. It has nothing to do with this problem. If you are stumbling, at least there is a helpful tip. But in the end, you can just go up, and all you need to do, if you're actually calculating a formula, this is the factor for this present value formula. And I said you're going to multiply this times 1,000, you're going to get 620.